All right, this is going to be for assignment 1, case 3, hybrid flow. Very quickly, I'm going to go a little bit faster through this video just because the setup is the same. The only thing that's different between cases 1, 2, and 3 is honestly just the boundary conditions. So just like case 1 and 2, the same setup is here. I sketched a two-dimensional shape, added the solid surface, added the length to be 500 millimeters, and added the height to be 10 millimeters, and I can actually show you that. Where is that? I believe is it here? Hold on, let me see. Length. So the way I can actually sketch, there it is. Height 10 millimeters and length is 500 millimeters. Just have to clarify that before moving on. Next, we're going to go to our meshing again. Again, this is the exact same process as I did in the other two. Automatic method, I did the edge sizing between the inlet and outlet. I did the edge sizing between the top and the bottom, 400 divisions. For the first one, I did 250. Base meshing just brings it all together and makes it all nice and organized and neat. Next, our name selections. It's the same inlet, outlet, top, bottom. All that's taken care of still. And the only thing we have to actually change is when we go into our setup here. So the only thing that's really changing is our boundary conditions, but I'm just going to show you really quick that the fluid is the same. For air, our viscosity is 0.001, 0001. Density is 1.225, just like cases 1 and 2. I'm going to minimize that. Our model, again, this is laminar flow, which is checked off. We're going to go to our boundary conditions. I can explain this a little bit. Because this is hybrid flow, you're actually going to have a pressure gradient that causes the flow, as well as a Couette flow that has the top plate moving. So what I did to have that be simulated is I did the bottom plate. I set that to a wall type, and it is going to be set to 0 velocity, stationary wall. Exit out of that. Our inlet, I changed to a velocity inlet as opposed to case 2, which was a pressure inlet with 0 pressure. But this is actually going to have a velocity of 10 meters per second coming in. Our outlet, this is going to be our pressure outlet. Let me snooze that really quickly. Gauge pressure is 0. That should be normal. Our top plate, I switched to a moving wall, just like in case 2, and set the plate to 10 meters per second, which will basically complete our boundary layers. Next, I go to reference values. We're going to be computing this from our inlet, which has these values right here. Next, we go to our initialization. We initialize. Hybrid initialization complete. We will go to run our calculation, making sure we have 500 iterations to make sure we converge to the answer, and we calculate. This should converge, I believe, at about 50 or so iterations, so it shouldn't take too long, as opposed to case 2 where it took about 141 iterations. So hopefully this goes by a little bit faster. Maybe a little bit more than 50. Possibly 70 iterations. Yeah. So it took 70 iterations to get our calculation. Now, once our calculation is complete, we can move on to let's go back to our workbench. And here, I'm just going to display the results now. So I'm going to open my results. We have green check marks all the way across, meaning that we are ready to simulate this. I'm going to very quickly share my screen so we can all see this, just like this. I'll wait till this loads up really quick. I'm going to set it to our Z or XY plane so we can see it easier. So just like, again, all the other processes, I'm going to insert a contour very quickly. I'll just call it velocity profile. I'll just call it velocity, in all honesty. So velocity. All right, velocity, so we'll call it velocity profile. We are going to do symmetry across the entire object. We are going to use our variable as velocity, and we're going to do 100 contours. And again, this is exactly as how it should look. I'm going to do a quick zoom in really quick to just illustrate this. So when your flow's coming in, it has approximately 10 meters per second coming in through the inlet, and the top plate is also going to be moving, so it creates this varied velocity profile, which you can see. When we zoom in super close, you can see it's about 10 on the wall, but it actually speeds up as it comes up like this. So it creates like a, you'll see in a second when I plot it, but it creates like a parabolic type shape, but not symmetrical. And again, that's due to the hybridization we did in this simulation. So I'm going to zoom out on this really quick, and I'm going to start plotting, begin to plot how these velocity profiles look halfway through the pipe and along the outlet of the pipe. So really quickly, I'm going to go to take off this velocity profile, insert location line. This is going to be our 250 millimeter line. This. And then we're going to set this to 0.250 meters on the x-axis and 0 on the y-axis. And for point 2, 0.250 meters. And our height is the height of the pipe. Apply. There's our line. Insert location line. This is our 500 millimeter line. So, okay. This is at 0.5 on the x, and then 0 on the y, and 0.5 on the x, and 0.01 on the y. We apply that, we get our little line at the edge. Next, once we have this, we can put our velocity profile contour back on. We can go to our chart. We'll just call this case 3. Okay. Chart viewer. Did I do that properly? Oh, I did not do that properly. So I'm going to actually delete this really quick. I'm going to delete. And we're going to go back to our 3D viewer, and I'm going to click this. And this is going to be case 3. Okay, it should prompt our chart view. Perfect. And this is, I'm going to title this case 3 hybrid flow. Okay, our data series. Actually, let's initialize our x and y axis. So our x-axis is going to be our velocity, u, and our y-axis is just going to be y. And for our data series, we have to now plot our two lines and where they're at. So let's see, this is going to be our 250 millimeter line at the line 250 millimeter. And we're going to apply. And that is exactly what we're looking for a hybrid flow. We're looking for that kind of parabolic shape, but not linear parabolic. And next, we're going to plot our second point or second line, which is going to be located at our 500 millimeter mark or the outlet. Our location, we'll choose the 500 millimeter mark and we'll apply it. And as you can see, our the velocity profile does change a bit from halfway to the end, which we do expect. And we get that exact shape we are looking for, which is again indicated with a hybrid flow where you have that velocity coming in through the inlet, but you also have that the feature of the Couette flow where you have that moving plate up top. And again, this is what causes that. And again, really quickly, I'll just go back to our contour. And yes, that concludes how to plot a hybrid flow in Fluent.